So welcome to the project demonstration of design and hardware implementation of closed loop buck converter using fuzzy logic controller. So the main application of this project is we are going to controlling the load based on the fuzzy logic inputs. So the fuzzy logic is input nothing but mainly microcontroller can provide us the logical outputs are two things. One is the Boolean logic, that is a 0 to 1, and fuzzy logic is incrementingly providing the output signal to the load based on the input signal. So which is done very smoothly without knowing the output signal in a digital manner. So actually it is nothing but the analog output, but it's kind of analog output which is gradually providing the output 0 to 1, slightly reaching up the load status 0 to high level, means maximum of output voltage, and that will be done with the help of this fuzzy logic circuitry by measuring the input and output voltage using these two voltage sensors, and that will be continuously monitoring by our PIC microcontroller based on the input signal from this variable resistor, that is a potentiometer. It will provide us the output fuzzy logic outputs to this two things. Okay, one is a transistor board and another is a fuzzy logic buck converter, so which is used to regulate the voltage based on the input signal. So we can decrease or increase the output voltage, which is very smoothly to the load section, and the continuously status monitoring on the 16:2 LCD screen. So this is the process of the project. To execute this process, we are providing 230 volts AC input to the transformer. This is the first stage, and the transformer will step down the 230 volts AC to 12 volts of AC, and the output of this 12 volts of AC is the input to the regulated power supply board, as which has three stages. One is the rectification, filtration and regulation. So after these three stages, it will provide us the two outputs. One is the 5 volts DC output, that is after regulation. So before regulation, 12 volts of DC output. So that 12 volts DC output is input to the circuit after buck converter, and the output of this is an input to the our load through this transistor board, which is getting the signals from our microcontroller to this potentiometer. And the same manner, the input voltage, output voltage will be continuously monitoring by these two voltage sensors, which will interface these to the A0, A1 pins of our microcontroller. We are using PIC 16F72 microcontroller, which is continuously monitoring of the input voltage from the reference voltage from this potentiometer, and output voltage from this buck converter to this transistor board, and also input voltage to this buck converter. So totally, like reference voltage, how much of voltage you need to provide to the load, as well as how much of voltage is getting into the buck converter, and what is the output voltage actually. Means we are setting the voltage, but we should check the whether it was reached to the reference voltage or not. Means reference voltage, input voltage after buck, if it is reached to the threshold voltage or not. Means the microcontroller has to be done this fuzzy logic controller for the buck converter implementation in closed loop manner. So it's keep on checking the input voltage and output voltage, whether it was reached to the threshold value which was set by the user from this potentiometer or not. So this is the process, and let us check the demonstration. So once we on the power supply to the kit, a welcome message displayed on the LCD screen. So you can see this. So once we restore this, so closed loop buck converter, and after this, so as of now the reference voltage is set to 0 volts and the input voltage is 22 volts, output voltage is 0, as we set that for 0 volts. So slightly I am increasing that, then it started providing the output voltage to this load. So it is increasing slowly based on the input voltage, means reference voltage. This is the reference set voltage to the load section. Right, maximum, as the voltage required to the load was set, reference voltage is 17.5, so I set the reference voltage, and the output voltage is 16.8, which is near to the reference voltage, and input voltage is 19.6. so we are doing the buck operation here completely to drive the load of DC. Right, here you can see this slowly. So the operation between the two input and controlling the output will take 1 second of duration. So just keep this at a certain value and leave that. Wait till the voltage reaches the level. Okay, so we directly increasing that, it will directly go to the high position, right, and again low position. So we can't get the like proper increment over there, so slightly do that to get the accurate output voltage with the help of the reference voltage by checking the input voltage to this load. Right, okay, so the duration for input and reference voltage input to output should check for 1 second of duration. Thank you.